This training module covers the synthetic vision system for the Embraer E2 aircraft. This material was developed by Honeywell's Flight Technical Services organization. For more pilot training and videos, go to pilots.honeywell.com. This presentation is Honeywell proprietary information and is subject to export restrictions and is intended for personal use only. The Synthetic Vision System, or SVS, enhances flight crew awareness by providing a synthetic, three-dimensional view of the surrounding environment, including sky, land, water, grid lines, obstacles, airports, and runways, in addition to standard flight and navigation data. The SVS uses obstacle and terrain databases to integrate existing flight deck data, field of view, and advanced symbology elements to assist in the pilot's ability to identify potential terrain and obstacle conflicts, as well as to identify visual references. Synthetic vision helps to reduce workload during certain tasks due to the increased amount of information presented to the pilot in a very intuitive way. During power-up, the classic PFD format is initially displayed. However, if there is a valid GPS position on power-up, the SVS may automatically turn on. SVS is controlled through the MCDU. Synthetic vision works by rendering terrain elevation data oriented in real time to aircraft attitude and altitude. When synthetic vision is on, all of the existing PFD symbology is overlaid on top of the SVS scene or terrain. The SVS is turned on or off by selecting line select key 6L on the display setup page on the MCDU. SVS and terrain sky elements are dimmable by selecting line select key 5 left and using the CCD knob to adjust. Line select key 5 right is used to control the topographical brightness on the iNav display.
Brightness control for the SVS stops at 25%. This ensures that the SVS cannot be dimmed to a black display. However, the topography brightness can be dimmed to 0.
When selected on, the SVS depicts a synthetic vision scene representing an out-the-window view of the surrounding terrain. The SVS uses the obstacle and terrain databases for rendering the SVS image on the PFD. Databases are updated periodically, and new updates are loaded via the data loader. The SVS obstacle and terrain databases have a worldwide area of coverage for reported obstacles taller than 100 feet and airports with either hard or soft runways. The terrain is displayed out to a range of 40 nautical miles from the aircraft's position. The display contains a green flight path vector, or FPV, that is conformal to the synthetic vision scene. The flight path vector provides a visual depiction of the actual aircraft path and has the ability to move vertically on the display. The flight path vector is always shown when SVS is enabled and is centered on the display. The Embraer SVS utilizes a track-centered design which provides the pilot with an immediate knowledge of the trajectory of the aircraft with respect to terrain. This means that the display is oriented to flight path and not heading. This design prevents symbology collision and occlusion of airspeed and altitude tapes by the flight path vector during high crosswind operations. When the flight path vector position exceeds the display limits on the PFD, the flight path vector becomes striped and is placed at the edge of the ADI area, indicating the FPV is not currently showing the actual path of the aircraft. Because the SVS terrain is drawn conformal to the outside scene, it is possible to orient the aircraft such that the entire rendered SVS terrain imagery is displayed outside the viewable region of the display. To address situations where there is a limited amount of SVS terrain visible on the display, a ground veil fills the area between the zero pitch reference line and the top of the terrain horizon. The ground veil ensures that a clear and unambiguous presentation of ground direction is always provided to the pilot. To address situations where there is a limited amount of sky visible on the display, a sky veil fills the area between the zero pitch reference line and the top of the horizon. Notice for excessive attitude, the terrain image fades out and the display format is blue over brown like the image on the right. Grid lines are regularly spaced, semi-transparent black lines overlaying the synthetic terrain. They convey a sense of motion as the aircraft is flying over featureless terrain. The grid lines run approximately true north-south and east-west and are placed at a distance of 0.4 nautical miles from each other. A range ring indicates what points on the terrain are at the same indicated distance or ground range from the aircraft. Range rings consist of range ring lines and labels. The rings are displayed at 3, 5, 10, and 20 nautical miles from the aircraft position and are conformal. Runways are displayed by the SVS when the length of the runway exceeds 3,500 feet. Runways begin to fade into view at 40 nautical miles and appear larger as the distance to the runway decreases. The FMS selected destination runway is displayed with a magenta outline, as shown here. The destination runway is highlighted on the PFD display only when the destination runway is one of the 10 remaining waypoints in the FMS. Hard surface runways are displayed with a runway designation, threshold markings, side stripe markings, aiming point markings, and a runway centerline. The runway pavement is displayed in dark gray. Runway designation and centerlines are displayed in light gray to approximate the appearance of actual runway markings. Runway designations that include letters are displayed with a letter below the number. Light gray threshold markings are displayed with a varying number of stripes, depending on the runway width. For example, 8 stripes is used for runways greater than 100 feet wide and less than or equal to 150 feet wide. Displaced threshold and stopway runway detailing are also displayed for applicable hard-surfaced runways. The glide path intercept point markers on the runway serve as a visual aiming point for landing the aircraft on the FMS selected arrival runway. The markers represent the glide path intercept point on the runway and serve as a reference point for the flight path symbol, or FPS. As the aircraft follows the defined glide path to the runway, the flight path symbol lines up with the markers. The airport symbol marks the FMS selected arrival runway. This symbol allows the pilot to easily identify the location of the selected arrival runway in the displayed terrain picture while the aircraft is still far away from the runway. The leading edge of the airport symbol is aligned with the arrival glide path intercept point marker to assist in positioning the flight path marker symbol. By aligning the flight path marker symbol with the leading edge of the airport symbol, the aircraft will be properly aimed at the glide path intercept point as opposed to the runway threshold. The 3D extended runway centerline, shown here as white dots extending out from the runway, gives the pilot a visual reference of the FMS selected arrival runway orientation while the aircraft is still far from the runway. When displayed, the runway midpoint is within 32 nautical mile ground range of the aircraft. The length of the 3D extended runway centerline is 20 nautical miles. All reported obstacles in the terrain view taller than 200 feet are shown on the display as blue images. Obstacles are centered at their respective latitude and longitude and are drawn to their published height. The width and depth of the obstacles are fixed at 100 feet. SVS obstacles begin to fade into view at 40 nautical miles and are fully in view at 27.5 nautical miles. Obstacles that are closer to the aircraft position appear larger than those that are further away.
The zero pitch reference line, or ZPRL, is the same as the horizon line on the non-conformal displays. The heading bug is a white lollipop symbol and is positioned on the ZPRL using true heading and drift from the selected IRS source. During an approach to landing, the heading bug on the zero pitch reference line aids the pilot in awareness of the aircraft drift angle. When the heading bug is off scale, it becomes ghosted or dashed on the ZPRL to let the pilots know it is not conformal. When in takeoff mode, the flight director is a dual Q cross pointer. Since the pitch Q is above the pitch scale, it is shown as a dashed line, which is parked at the top of the pitch scale limit. As the aircraft rotates, the aircraft's pitch angle increases, and the aircraft will be higher on the pitch scale. The dashed line Q becomes a solid line when the takeoff pitch command comes into view. The transition from dashed line to solid is smooth and can be easily followed by the pilot during the takeoff rotation. The dual Q command remains on the ADI until another vertical mode is selected. Synthetic vision is available for altitudes up to 55,000 feet MSL, but reverts to the classic PFD format for the following conditions: beyond 70 degrees north and south latitude, if the SVS is off, failed, or unavailable, or when the SVS is initializing. The PFD will automatically revert to a blue over brown format when the aircraft exceeds a roll angle of 65 degrees and the pitch exceeds 30 degrees pitch up and 20 degrees pitch down. In the blue over brown format, the terrain wallpaper is simply removed from the display and the display declutter logic is activated as shown here.
In the event of an SVS failure, the SVS fail annunciation is displayed on the ADI. The synthetic vision terrain image is removed and the display reverts to the classic PFD format. For more information on Honeywell products and services, go to www.honeywell.com.